So in our previous video, we figured out, given a certain mass of each of our reactants, how much of our solid product did we make. And in this last step of that, we determined the molarity of the solution, and that molarity would be of the ammonium chloride. So let's take a look at this and ask ourselves then, how can I break this into an ionic equation? So first let's start with a net ionic equation. And what I want you to do is pause the video and decide which species are going to break apart and which species are going to stay together, and what are the charges on each of my ions or molecules when I do that in an ionic equation. Alright, so let's take a look. Let's see, I have here, that's a polyatomic, that's a polyatomic. The bond between nitrogen and hydrogen is covalent. The bond between sulfur and oxygen is covalent. We do not ever, never, never, ever, never, never, ever, never, never, times like 8,000, break covalent bonds in water. So that tells me I can start off here and be like, okay, I have 2 ammonium ions, because remember that subscript there says that I have 2 of these things, right? So I have 2 of those, and that looks like a Y, not a 4. And those, that's aqueous. I have 1 sulfate ion, and that's aqueous. So now let's look at the charges on these. Let's see, if I bring this 2 up here, because I've forgotten that SO4 is 2 minus, then I can use that to remind me of my charges. And I look at ammonium, I can either use the subscript, I have 1 sulfate to 2 of these, that means this must be a +1 charge. Or you can go ahead and do a Lewis dot structure and figure out what the charge is from there. Let's see. Now let's come over here to this. I have a calcium and a chlorine. Let's see. So this is a metal, non-metal. This is definitely ionic. And let's see, this 2 subscript here tells me that calcium is 2+. And there is 1 calcium, so I know that chlorine is -1. Now what I haven't done here is there are 2 chlorines, so I need to make sure that that 2 goes here. I'll make that neater. +2 Cl-. Now, one thing I want to emphasize is what you don't have and what you will never write. So you will never write this. That is not true. This is not, this is bad, 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 no, bad, no, don't do it, don't, no, 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 okay? So these are the ions. Now let's go to this side. Calcium sulfate is a solid. We do not break solids up into their ionic pieces, so that stays itself. And starting to run out of room. Let's see, I have ammonium and chlorine again, so I'm going to have 2 NH4. Let's see, we already determined that was +1, +1s, plus 2 chlorine ions. Oops, forgot the 2. 2 chlorine ions, -1, and that's aqueous. I'm running out of room, aqueous. There we go. Cool. So that would be a total ionic equation. A net ionic equation says that we have these things called spectator ions. Spectator ions just pretty much hang out and do nothing useful in life. And so a net ionic equation says we want to look to see what is actually producing something. So the one thing I look for is, does anything appear on both sides of the equation? Let me use a different color. There we go. So let's see, I have 2 ammonium ions on both sides. So that would be a spectator. I'm just going to draw a green line through it. That would be a spectator ion. I have a sulfate ion on this side and nothing on that side, so that stays. I have a calcium or Ca2 plus ion on this side and no Ca2 plus ion on that side, so it stays. But I have 2 chlorine ions, so they exist on both sides of the equation, so they would go away. So my net ionic equation then would be, let's see, Ca2 plus aqueous plus SO4 2 minus aqueous, forming CaSO4 solid. So this is a net ionic, and this is the total ionic. Now you have it.